Welcome, being outside. It is now, look at that, 60 degrees outside. What a nice day to be outside, taking measurements with snow. So let's get some snow. Ah, here you go. You can do this at home if you want, for fun. Let's see, we got a container of snow. Wonder what temperature the snow is. Let's do it in 60 degrees Fahrenheit. Let's do some Celsius because us science people like it in Celsius. 15.7 Celsius. Let's throw it in there and we'll see what happens at the thermometer. There we go. Let's see. There we go. Let's see if I can get it so you can see it. Let's see. Oh, it's upside down. My bad. Okay, now take it again. Here you go. Ooh, look. The snow is 0 degrees Celsius. Even though we're outside and it's 60 degrees outside. I wonder why. What if I let this sit in the sun and melt a little bit? I wonder what's going to happen. And if you want to see Fahrenheit, just for giggles, 32 degrees, which is freezing in Fahrenheit, but we use Celsius in science. So there it is, 0 degrees. Oh, look at that. My snow has melted a whole bunch. I wonder what temperature it says. Oh, 0 degrees. Even if it's melted, it's still going through a phase change. There's still snow in there. And that snow is still a solid. So during the melting, the phase change, 0 degrees Celsius. I wonder what happens if I'm going to add some salt to this. That's going to be the next experiment. Okay, so here we have some more snow. And look what temperature the snow is at. 0 degrees Celsius. Because the snow is melting. But what happens if I add some salt? Why do you put salt on ice? That is an awesome question. What does the salt do to the ice? Let's stir. Ooh, something's interesting is happening. The snow is getting a little slushy, but look at the thermometer. Minus 2.5 degrees. Let's stir it some more and see what happens. Uh-oh. Don't want to get any snow on my keyboard. Minus 11. Oh, there we go. Ah! There goes snow on the keyboard. Look at that. Minus 11 degrees. Wow. Let's add some more salt. Ooh, this is going to be delicious. Salty. Don't get salty with me, Mr. G. That's what the snow's saying. Oh no! What's happening? What's happening to me? Oh no! What's the salt doing? What is the salt doing? Whoa! Look at that. It's making the temperature go down. How is it making the temperature go down? Is it making... What's happening? This is the colligative properties. Ooh, big fancy word. But this is the reason why you put salt on the road what it does is it lowers the freezing point. And look, it's lowered. It lowers the freezing point. So notice it's getting slushy in my little container here, and that's what happens on the street, is that when you add salt, it lowers the freezing point due to the colligative properties. Ooh, almost 20 degrees below. So now, for it to be frozen solid, instead of being 0 degrees outside, it has to be negative 18 degrees. Ooh, almost negative 20. It has to be 20 below 0, and that's Celsius. I wonder what that is in Fahrenheit. Let's hit the button. Wow. -2 degrees Fahrenheit. Whoa, that's really, really cold. Wow. So let's go back to Celsius. So -16 degrees Celsius. Let's stir it some more. Let's see what we got. Oh boy, it's getting exciting. Now, of course, you can do this at home. Look at that slush. Look at that slush on the bottom. It's turning to slush. That's what we want on the roads. We want slush on the roads, not ice on the roads. But look at the temperature that slush is at. Wow. Almost negative 20 degrees, negative 19 degrees. So even if it's negative 19 degrees outside, negative 19 Celsius, the roads still don't freeze. That's why you put salt out on the roads, because it lowers the freezing point. As you can see, -20 Celsius. And for you Fahrenheit people, freezing point of water is 32, so -2 degrees, minus almost 3 degrees Fahrenheit, -3 Fahrenheit. That's really cold outside. And if it's this cold outside, well, then ice I guess it's still slushy, so it would even work if it's that cold outside. But that is why we put salt on our ice to melt it. By lowering, it depresses the freezing point, which makes slush instead of ice.